Hello everyone, welcome you to the 6th International Conference on Imaging Vision and Pattern Recognition and 11th International Conference on Informatics, Electronics and Vision, University of East London, UK. I'm Koushick Barua presenting our research paper entitled An Improved Framework for Classification of Skin Cancer Lesions using Transfer Learning. So this slide is for our outlines, which we will follow throughout the presentation. So this is our introduction part. Skin cancer is one of the most common type of cancer. Nowadays, it is very harmful. Without proper diagnosis, it causes death. Skin cancers can look quite different from one person to another due to skin tone, size, and type of skin cancer and location on the body. The main causes of skin cancer are the sun's harmful ultraviolet rays, and most skin cancer is treatable if it's caught early. Early detection and diagnosis can save millions of lives. This is our motivation. Accurate diagnosis and classification of skin cancer are crucial for effective treatment and patient care. Traditional methods for skin cancer diagnosis may have limitations in terms of accuracy and robustness. CNN and deep learning techniques have shown promise in medical imaging analysis tasks. Leveraging these advanced techniques could lead to the improved skin cancer diagnosis and classification. This is our research challenge we have faced. There are 7 level class images in this ICIEV 2018 dataset. Hard to classify, but not impossible. Overfitting and generalization challenges with this complex imaging dataset and model improbability for clinical decision making and robust computational resources constraints for training and CNN with deep transfer learning. This is our aim, which is to explore the application of deep transfer learning techniques for improved diagnosis and classification of skin cancer for proper detection and diagnosis, implementing a system that uses deep neural network learning algorithm. So this is our research objectives. Investigate the model performance with other existing models, investigate deep learning for skin cancer diagnosis and classification, compare with traditional methods for superiority in skin cancer classification, enhance accuracy using pre-trained models and diverse medical imaging datasets, provide insights on the potential for improving skin cancer diagnosis and patient care. This is our proposed methodology for convolution neural network. First, we have taken the input images with input size 2828 into 3. Then image processing part has done, which I will cover later in our slides. And then we augmented our images with shift, horizontal, vertical shift, zoom, shear range, brightness, saturation. And after that, we featured our images feature extension with CNN and classify with this CNN. And finally, the output layer we have added. This is our ICIEV 2018 or Human Against Machine 10,000 dataset downloaded from Kaggle. There are 10,015 images. Some sample images are shown in this figure. This is our dataset in table with melanocytic navy has the 6,705 images, which is the highest, and second highest is benign keratosis lesion, has the approximate 1,100 images. This is our image preprocessing technique. First of all, we resize the image as 2828 into 3 for convolution neural network, and also all the transfer learning models we use 224 into 3. Then that augmentation part we have added, and the normalization part. This is our proposed CNN model description. Sequential of convolution layer we have added, and some max pooling layer, and some dropout layer, and flatten layer, and 2 dense layer, and finally an output layer with 7 nets with activation softmax function. And optimization function we used is Adam optimization, and learning rate is 0.001, and loss function we have used, which is categorical cause and topic. So this is our transfer learning models. We have used 5 transfer learning pre-trained models, which is 16 mobile net version 2, DashNet 201, ResNet 50, and Inception V3. After that, we use some additional layer. This is our Inception V3 model, which is the highest accuracy. And input size is 224 into 3, and sequential of some convolution layer, and some dense layer, some dropout layer, and finally output layer with 7 nodes. Optimization function we use as convolution neural network, and learning rate is 0.01, and loss function is categorical cross entropy. This is our result analysis part for model performance, where inception P3 is the highest 0.97%, and proposed CNN convolutional network model has the close to inception P3 model with 94% accuracy. This is our curve for inception P3 model and convolutional network model. These are confusion metrics for both inception P3 model and convolutional model, where melanocytic navy has the 834 images are currently predicted for inception P3 and 1213 images for CNN model. These are conclusion part. When we investigated the deep transfer learning for skin cancer disease detection and classification, transfer learning model exhibits higher precision, sensitivity, and especially compared to the other models, achieved 97% and 94% accuracy on ISIC 2018 dataset and healthy controls using inception P3 and proposed CNN model. These are contributions with the how our model is accurate, how they contributes by systematically evaluating CNN and transfer learning models, resulting in an effective algorithm for skin cancer classification, offering insights for future research using human against machine 10,000 dataset. These are future work, balancing the imbalanced dataset for proper and accurate classification of ISIC 2018 and 2019 dataset, investigated on ISIC 2018 and 2019 skin cancer images challenges, investigate transfer learning across diverse medical imaging models for better cross modality and transferability. So there are some references we have added. Out of 40 references, we included here is 6, which is most important. Finally, thank you.